Hi everyone, I'm Arihan Jain. Today we will be talking about Antarctic oscillations. There are certain drivers of climate variability in the Southern Hemisphere. One of these is the Antarctic Oscillations. It is also known as Southern Annular Mode or SAM. In the Southern Hemisphere, there is a high pressure zone around the globe in the subtropics. This is called the subtropical ridge. On its southern side is the strong westerly winds like the roaring 40s and the furious 50s. Antarctic oscillations refer to the north or south shift of westerly winds in, in the southern hemisphere. This shift in winds can disrupt weather system around the southern hemisphere, including those that bring rain to South Australia. Antarctic oscillations have three phases: positive, negative, and neutral. These phases stay for usually 2 weeks, but sometimes even longer. In winter, these westerlies lie in parts of southern Australia. This causes cold fronts to be drawn northwards, bringing winter rains. If these winds move towards Antarctica, the rain systems also head south. This means fewer fronts and drier conditions in Australia. This southern shift is called positive Antarctic oscillation, but this also means that parts of eastern coast get rains as more tropical air gets southwards. The opposite is negative SAM, which occurs when the westerlies move northwards, causing more cold weather to be drawn from south. This negative SAM in winter helps get good rainfall in alpine areas. But if it gets too far in the north, the westerlies will be wet in the west but dry by the time they reach the east coast. Impact of Antarctic oscillations is just the opposite in summer when subtropical ridge is at its southernmost position, and this decreases impact of westerlies on the rainfall as westerlies move further away from the coastline. But if they do reach northwards in summer, that is negative SAM, more dry air blows on eastern Australia, resulting in below average rainfall. During positive SAM in summer, the ridge shifts southwards. This expands area, receiving moist tropical winds on the east coast. Now, talking about the impacts of Antarctic oscillation, it has different impacts on the rainfall and temperature patterns across Australia, depending on the season and region. This figure shows the average impact of southern on annular mode SAM, its positive phase on rainfall in Australia across a large range of events from 1979 to 2005. It helps to predict heat waves, floods, droughts, snowfall in different regions, especially coastal regions, which have the highest concentration of population, such as around Sydney, Melbourne, and other Tasmania, etc. So during spring, the SAM's effect on rainfall can resemble a weak summer pattern. A positive SAM decreases the chance of heat waves in southern Australia, while SAM has little effect on during autumn, but a positive phase can decrease the chance of extreme heat in the northern and central Australia. This Antarctic oscillation is often related to ENSO events. SAM is positive during La Nina and negative during El Nino. Range of each SAM event can be random, ranging from 10 days to even a few months. In recent decades, there has been a positive shift in SAM, resulting in weather systems shifting southwards. As you can see in this figure, there is a more trend towards positive SAM events in the recent decades. This is the highest in the past 1,000 years based on tree growth records and ice cores, mostly attributed to ozone depletion, and greenhouse gases. This Antarctic oscillation is a crucial driver of climate variability in the southern hemisphere. It is also linked to Antarctic ice melts, and overall, this plays a key role in determining the climate of southern hemisphere. Thank you.